welcome to the session. So now in this particular video, we will discuss one very interesting interview question which can be asked from you with respect to a stack-based data structure, which we have already discussed, right? I hope that you must have encountered this question a lot while giving the interviews, because again, this is very frequently asked question. So let's get started. First of all, I'll try to make you guys understand what's the problem statement all about. Please try to understand the problem statement first, followed by the concept that how basically we can solve that problem via a stack-based data structure. Okay. The problem is all about a valid parenthesis, and you can find a similar problem on the LeetCode platform as well. So here the problem is about a valid parenthesis. Fine. What this problem says, let's try to understand the problem. This problem says that I will provide you a string, maybe a string of characters which indicates a parenthesis. 3 different kinds of brackets are given to you. This one is one type of bracket, this one is maybe another type of bracket, and this one is maybe another type of bracket. Now, what you're supposed to see, for example, if I will provide you a string which is composed of like this one, then this one, then this one, and then this one. This is a string which is given to you by the user. You have to tell me that whether this string contains a valid parenthesis or not. Now, what is the definition of a valid parenthesis? The simple definition of a valid parenthesis is that for every open bracket, there must be a closing bracket, very first point. For every opening bracket, there must be a closing bracket. For example, here you can see that for this particular opening bracket, I have a closing bracket. For this particular opening bracket, I have a closing bracket. Second really important point here to understand is the order. Is the order by which it makes it to be a valid or invalid. For example, if I'll say like this, maybe this one, and after that this one, after that maybe this one and this one. Now here if you will observe, this is not a valid string or valid parenthesis. Why? Because here if you will observe, what you can see, there is a closing bracket corresponding to that. Okay, there is a closing bracket corresponding to that, but there is not a closing bracket for this. So how basically I'll try to understand with respect to my code that okay, this is something which is a valid one, and my code will give a response or the output that whatsoever is a string is entered by the user indicates a valid or invalid. For this, what we can do, just think over it, just pause the video and first of all think over it that how you can basically solve this kind of a problem. I hope that you already have give a thought about this. Now let me share my approach with which I think is the best one to see according to this particular question which is given to me. Here if suppose I'll create a stack. If I'll create a stack, what is stack? Stack is a data structure basically used to implement a LIFO kind of architecture. LIFO means last in, first out, right? We already know all these things. So I'm sure you already know, so I'm not explaining those things again and again. So what is happening here, that what I will do for every open bracket, what I can do, I'll try to store that inside my stack. For every open bracket, I'll store that character inside the stack-based data structure. So here if you will observe, we will be having the very first character inside the string as the open bracket only. So what I will do, I'll start, so this is I value 0, this is I value 1, this is I value 2, this is I value 3. Now what is the open bracket? this can be an open bracket, this can be considered as an open bracket, and this can be considered as an open bracket. So if I will see in my character out of these three characters, what I will do, I will simply try to store them inside my stack. So basically this first character at 0th place will go inside my stack. So I will append my stack. Now if I'll go to the I equals to 1, again there is an open bracket. So again I'll try to store that inside my stack. So this is something which I have is a stack based data structure. Please focus here, it's quite easy, but sometimes students got confused. Please try to understand here. Now if I'll go to the next particular bracket, you can clearly see it's a closing one. So what I will say to my code, for every close bracket, what you supposed to do, just pop the element from the stack. Just pop the element from the stack. So here if you will observe what I am trying to do, because in the second, when I equals to 2, I am getting a closing bracket. What I will do, I'll just pop it out. When the value of I is equals to 3 at the next place, again I am getting a closing bracket. Obviously you need to see a pair. So what is a pair? This is pair number 1, this is pair number 2, this is pair number 3. You just need to map that, okay, this closing bracket belongs to the upward element, the topmost element inside the stack or not. Is there a mapping between these two or not? That's important. Then only you can pop it out, right? In the next case, again, at the value of I equals to 3, you need to see that whatever be the mapping of this third place, is that true? Yes, it's true. There is a proper mapping of that. Again, I'll try to pop it out. Once you will reach at the end of the string, if it's a valid string. So the important point here to understand is that if there is a valid parenthesis, that is for sure the algorithm simply suggests that you will be having a empty stack. Otherwise you will not have definitely, right? So here if you will observe, after approaching towards the end of the string, my stack is empty. I don't have any element present inside my stack currently. Consider in a case where there will be any element which is left inside the stack, it simply indicates that this is not a valid parenthesis. Making sense? I hope that now you will be able to get an idea that how basically with the help of a stack we will be able to determine that whether that stack belongs to a valid parenthesis or not. Now what we can do, whatever I talk about here, whatever I have talked about here, I'll try to do the implementation of the same in a very concise manner. So what I can do, let me open my Jupyter notebook. First of all, what we will try to do here is that we will try to write a driver code. So basically here I will write a driver code where I will write a string which basically contains first of all, let me take a valid case, then I'll show you invalid case also. Or maybe I can say it's a string 1 and we can take a string 2 for an invalid case so that we can examine both of the test cases. So maybe I'll take like this, then I'll take like this, then maybe I'll take like this. This is something which seems to be invalid to me. Okay, let's see whether our code will also say the same thing to me or not. I'll try to create one function and that function will return a boolean value, either true or false. So the function name is valid parent, okay? And inside that, obviously you will pass the string. String 1 as of now you are passing, and if it is valid, it should print that string is or string contains valid parenthesis. Otherwise it will say to me or print to me that the string contains an invalid parenthesis. Okay, string contains a valid parenthesis. Otherwise it will say to me that string contains an invalid parenthesis. Now here, the next important thing to write is the method definition. So here we will try to write it down, the method definition, which is of is valid parent, is valid parent. So here what we can do, we can try to just copy this function name. Maybe I'll take the string which is entered by the user here. What we supposed to do? Maybe I can take one set here which contains open parameters, which contains all the open parameters here. Okay, so open param, and here I can create one set which is composed of three things. One is this bracket, another one is, I believe, this bracket, this one, and another one is, I believe, this type of a bracket, if I'm not wrong, right? All these indicates open parameters. Now another thing which I will take is a dictionary where there is a proper mapping of what is closing and opening bracket. For every opening bracket, there should be a proper mapping with the closing bracket, because how code will get to know? See, we know that, okay, this is a valid parenthesis, or this is a mapping of the parenthesis, but how code will know? We have to tell them, right? So here we can maybe create a dictionary kind of a data structure where I will be having a key value kind of a pair. So here if you will see, I can create a key as the open bracket, and the value for that particular key is the closing bracket. Similarly, here what I can do, I can create this as the key and this as the value. Similarly, I can create maybe this as the key and this as the value, right? Now once the dictionary will be created, now I need to traverse each and every character present inside my string. So what I will do, I will make a for loop for char in my string which is given to me. What I supposed to see, that if that character is present in my open parameter, then what do I supposed to do? In that case, I just need to append it inside my stack. For this, one new thing came into my head is we need to initialize a stack. So stack is an empty list as of now. And now we all know that in order to implement a stack based data structure, we need to use the append and pop function, right? So what I can do, I can just simply append the data inside my stack. I can append the character inside my stack whenever I am seeing an open parameter. It's done. Now, if that is not the case, and my stack is also not empty, my stack is also not none, and the value of the character is equal to dictionary of stack of -1. Now see what is happening here. What is the meaning of stack of -1? Means I am pointing to the last element. Last element, stack is something which is LIFO only. So I am pointing to the last element in the stack, and that will be the key. And you all know that in a dictionary, when you will create a dictionary of a key value pair, dictionary data structure is something which is a key value pair only. At that time, when you write inside a dictionary, you will write dictionary, and inside that, if you will write the key, you will get the corresponding value for that. So what you are saying in your code, I am saying that go to the last element present inside my stack. Maybe in this stack, this was this particular element open bracket, and I am passing this particular open parameter inside my dictionary as a key, right? I am passing this as a key. So what it will return? It will return the corresponding value, which is this. So I am saying, is my upcoming character is equal to this closing bracket or not? When the value of I is equals to 2. Yes, it is true. It's a closing bracket which is equal to this only. So what I supposed to do? I supposed to pop out of the stack, and that is what I will do now. See? So what I will do here, if that is the case, do one thing for me. Do stack.pop. So whenever I am seeing a open parameter, I will add the element in the stack, and whenever I am seeing that there is a closing parameter, what I am doing here, I will pop, or you can say delete the element from the stack, That is what we are trying to do here. Making sense? Making sense? Now, if that is also not the case, in else case, if that is also not the case, simply we can return the value as false. Meaning, if in a scenario where I am getting a stack topmost value which is not equal to the character which I am looking for currently, at that point of time you can directly return to the else condition and return the false. If that is not the case and you are running out of the for loop, you can simply give a check. You can simply give a check that whether the stack is equal to the empty list or not, right? Whether a stack is equal to the empty list or not. Now this is something which is an assignment operator. If it is equals to empty list, at that point of time it will return the value as true, otherwise it will return the value as false. That is something that we are getting here. So this is something which we will be able to see. I think we are done. Why? Because this is what we have talked about, the logic in the blackboard. So let's see if we're getting some error at that moment itself. We will try to resolve it. So as of now I'm passing a string 1. It means I should get a valid parenthesis, right? The first statement should be true. Let me try to run this code. Let's see. So we are getting some error. Let me try to figure it out. What's the issue here? Yeah. So here we are creating a set. Inside that a bracket should be there. So here, okay, this is fine now, I believe. Let's see now. Yes. So now we are getting that string contains a valid parenthesis. Now what I will do, I'll just try to verify with the string number 2 also. What we are getting now, if I run this code, I'm getting string contains an invalid parenthesis. Why? Because if you will try to run this particular code, what you will get? So here if you will observe, what I am having is, let me just try to open it up. So what I am saying, I am having something like this. This one, then this one, this one, this one, and this one. It's clearly visible, right? I'll start from here because it's an open parenthesis. So what I'll do is that I'll just try to enter it inside my stack. After that, again, it's an open parenthesis. I'll just try to enter it inside my stack. Again, it's an open parenthesis. I'll try to again enter it inside my stack. And I think third one is the closed one, I believe. So if it's a closed one, it will go inside my second condition and it's just verify what is the topmost element, the last element present inside my stack. It's true. So there will be a popping here. So I will move ahead. Now there is a closing one, but here if I'll just do the mapping, this is not which I am looking for, right? This is not which I am looking for. So it will go inside the else condition and directly return false to me. And once it will return false to me, it will go inside the driver code. And because it's false, it will return that it's a invalid string. It's an invalid parenthesis. So I hope that I'm making sense to everyone, right? This is a very easy question, I would say, but this is easy for those who are having a great understanding about what stack data structure all about and how will it work. Then only you will be able to understand the complete end-to-end understanding of how this question is implemented, right? I hope that I'm making sense to everyone. Now, what do you think is the time complexity requirement for the same? So here if you will see only one for loop we are applying in order to check that whether it's a valid one or not. So it clearly indicates that the time complexity requirement for this particular code is something which is equals to big O of n, where n indicates the size of the string that we have. Why? Because here time complexity is all about looping, and here we can see that we are applying only one for loop which is traversing throughout all the characters present inside the string, and here we are having if else condition. Quite simple, right? So with this I would like to end this particular video. I hope that you really like the video a lot. If you still have any sort of doubt, do let me know. I'll for sure try to resolve it as soon as possible. With this, happy learning to all. Bye bye everyone, and I'll see you all in my next upcoming video.